Hello everyone, my name is Gary. Welcome back to the garage in Spain, home to Abril Junction. As there's very little to report on the actual layout construction this month, I've decided instead to present one of my How I Made This videos. Now the intro will have given you a clue as to what this will be, and in this case I will show how I install end of train lighting to my carriages and wagons. I have included a list of all the parts and tools required, and these are shown in the Show More tab of the video below. Now I have to add that I am not affiliated to or receive any financial rewards from any of the manufacturers or distributors of the items. Okay, enough waffle, let's get to it. So for this particular project I've decided that I want end of carriage lights on this brake van. So first thing I do is remove the body obviously and check that I've got sufficient space within inside that I can actually put the electronics without being seen through the windows. It can always be masked off, but ideally a brake coach you can't actually see inside. So I've taken off the bogies because obviously they will be in the way now. The important thing for this project is that you will need metal wheels. They don't necessarily have to have a metal axle. On these particular ones they do, but what I have found that these particular wheels have little stub axles which actually are insulated. To take the power from each wheel up into the circuitry, I first of all decided to use a balsa wood block which would be mounted underneath the chassis, onto which I would attach some wiper blades. Now these were purchased from Marklin, they're still available, and they won't just make one truck. I mean, the amount of copper on these is quite in excess of what we need, so obviously you can make plenty of models and use them in the future. So using an ordinary pair of scissors, I first of all just cut off the wipers to sensible length strips of copper. The attached wire that they come with I won't be using because that's a little bit too thick for this purpose. The pieces of copper need to be glued into the small piece of balsa, and here I've done that using a little bit of Abril or epoxy resin, something that's really stiff. Super glue certainly isn't that brilliant because the bond between the metal and the wood isn't always that great. And I've attached two single core copper wires which are obviously insulated. You can find these in old motors. The winding wire is excellent for this. It's very light and very forgiving. And then it's just a matter of making sure that with a slight bend in the copper, you'll see that now it's in position. The two copper wipers touch an individual wheel. And obviously we'll be picking up either AC or DC and sending it back up to the electronics, which we'll talk about in a moment. But again, your chosen method of securing that. Again, I used a two-part epoxy resin, which was fabulous, Abril, that type of thing. You will have some friction on the wheels. There's no doubt about that, but again that can be adjusted by bending the copper slightly, so as long as you've got a good contact, that's fine. This is a little 3D print I experimented with, and basically it's just to keep things a little bit neater and tidier, and for me to practice with my 3D printer. And again, both pieces of the copper will fit into that particular module, then that again is stuck to the bottom of the bogie. And here you can see the two wipers in position. One end will obviously have the cable attached to, and that goes up into the chassis. And as I said again, this just gives you the advantage if you're into 3D printing, then it matters not whether you use that or the balsa. So the next thing to do is to drill a separate hole through the bottom of the main undercarriage and a corresponding hole once the bogie is put back into the actual boss on the undercarriage, so that the cables can go up here they'll obviously be thin enough to go through. I don't use the hole that's cut for the actual bogey fixture because it can trap the cables, so a separate wire is much better. Okay, now onto the LED itself. Again, I've put all the part numbers and suppliers of these in the comments below, so you'll be able to get that off of the video. But basically we're going to use a red LED. First of all, I paint this with a black undercoat or primer, and then paint the actual top colour, chosen colour, in this case white. And at this stage that's all you need to do. Don't do any anything other than that. It's just paint it with an undercoat and your top coat colour. Next, the actual guts, as it were, of the module. It's based on a capacitor, and if you haven't seen one before, this is a capacitor. It's 1000 microfarads. That's the capacity that it will hold of electricity, and that is the rating for the voltage. That's 25 volts. And very much like an LED, it has a negative and a positive connection. And as you saw there, the negative is easily shown, and the longer leg being the positive. The other thing we're going to need is a bridge rectifier. This basically converts AC current into DC, and will also take DC current and provide a defined positive and negative output. So you have two inputs, and the two inputs take AC or DC, but the output is only ever a positive and a negative DC. And as you can see a little bit clearer on this diagram, left and right is showing inputs of DC plus or minus either side, and AC, which is obviously alternating current from both sides, but you will always only ever get a DC output and a DC negative output. So this is a bridge rectifier, very, very useful. So if your train goes in reverse on analog, the lights will still come on. Whereas normally with analog, when you reverse the current, the LED won't light because of the fact that it's a diode. And basically, a bridge rectifier is a series of diodes, if you like, that will only allow current to flow in one direction. So that's a very useful little item. That can also be used for doing your carriage internal lighting as well as a little light on the back, but that's in another video. So the next thing to do is to get this ready to assemble. Now, these are very forgiving legs. Each one corresponds to either the two inputs or the two outputs, which is shown on the top of the actual piece. So the way I do this, and the reason I've used this particular 1000 microfarad capacitor, is that it fits together in a little unit, and it's done quite easily. Now, the important thing to remember is that you must get the negative lead of the capacitor connected to the negative output, the DC negative output of the capacitor. But again, there's symbols on the top of the rectifier, and it's easy enough to marry those up. This is just a bit of fiff-a-faffing around just to get the thing ready. But you'll see that once it's in place, it's very firm, and it will only need at the very end a little bit of soldering, which I know a lot of people sort of shy away from, but it's not too difficult. So I've now positioned the capacitor on top of the rectifier. I bend the two input legs out of the way, because at the moment we don't need to worry about those. And it's just a case of simply bringing one arm down, as you can see there, and then twisting that round, and then doing the same for the other side as well. As you can see, the wire is very malleable, and 3 or 4 twists is all you'll need just to tidy things up. And again, this is just the initial stage. We'll trim those off in a few moments and then just blob a bit of solder on there, and the addition of a resistor, which we'll come to in a moment, just to complete this side of the item. Next we move on to the position for the light itself. I personally put my lights on the back of my train. I don't want to ruin anything, the detailing on the back, so I find a suitable place where the light will look best. So again, with the LED still untouched other than being painted, it's just a case of drilling two very small holes through the chassis, through the bodywork, and positioning the LED to where you want it. Here it's between the two stays and also some extra detailing. As I say, I don't want to destroy any of that, so I just put it in where it will go. And as far as I'm concerned, as long as I've got a rear light on, that's fine. If you want to be more prototypical, then check out stock photographs and make sure you get it in the right place. However, when the wires are through from the LED, remember which one is the positive, the longer leg, cut them down, and then have a test fit to make sure that where you're going to put this back into the actual carriage, nothing fouls the cabling or will foul the cabling later. And here you can see I've got plenty of clearance because it just happens to have a cutout on the floor section. The little unit, and as you can see there, I've now soldered each end, the blob of solder, and added a 1000 ohm resistor. That's very important because otherwise you would have the full either 12 volt or 16 volt going through your LED, and that will pop it instantly. So you must remember. Now I personally, just for remembering everything, always solder my resistors onto the positive leg. And you can see on the bottom there, I've trimmed down the two incoming legs as well. So with the bogie now in situ, with the wiper blades attached, the cables pushed back up through the hole from the base of the bogie. Check that you've still got connection with the actual wipers onto the wheels. Pull your wires up through the first hole in the bogie, and that will then obviously push back through the floor of the actual carriage. Now here you can see I've taken the two cables that came from the bogie and connected them to the bottom of the capacitor, and it doesn't matter which way round you do that, that's not important. Then I've taken the feed from the positive of the capacitor, the output to the positive side of the LED, and the other cable is the return. So it's a simple little diagram. The two inputs, doesn't matter which way round, but the outputs to the LED, the positive must go to the positive leg of the LED and the other wire to the negative. Then it's a case of carefully fitting that in. I use some blue tack to hold it in place, close the top down, and then using a very small piece of sandpaper, and this is where the careful use of this will be shown. Just carefully wipe the back of the LED until you've broken through to the actual lens itself. Now, first of all, do it and you'll get a tiny little red light, and depending on how bright you want it, take a little bit more off if necessary. Now, the reason for the capacitor is that if you get a break either going across points or a bit of dirty track, there won't be a flicker because the capacitor holds the power in, even if there's nothing coming into it. Here you can see I've taken my little class 8 just to pull these coaches across the points, and you'll see that there's no flicker. And if you pick the carriage off the track, it will actually last for about 15 to 20 seconds, depending on the size of the LED or the number of LEDs used. So that's my take of end of train lighting, and I hope you found the video of interest. And if you have any questions arising from this project, please leave them in the comment section below the video, and I'll certainly find time to reply to all of them. Please consider giving the video a thumbs up, as this will help to promote it within the various hobby sections of YouTube. And if you'd like to receive more content from my channel, along with notifications of when I upload to YouTube, perhaps you'd like to subscribe to the channel. I'll leave a link here for that, and also there'll be a link for a previous build video that I've published on the channel. As ever, stay safe and well. Thanks for watching. Until next time, cheerio.